Alright guys, so now we're starting to get into some word problems on our trigonometry. It's getting a lot more exciting. So what we see here is that Vlad is playing on a swing set, and his horizontal distance from the center, where behind the center means a negative distance as a function of time, can be modeled by a sinusoidal expression of the form a cosine of bt plus d. So you can think about a swing set. It's really just it's kind of periodic behavior. If you're to draw, here's the swing set, and here's somebody on the swing set. Really bad at drawing. There's the cable. But you can picture they go forward and they go backwards, going back and forth. So we're kind of modeling this situation using trigonometry. And you can picture the sine curve going like that, or cosine curve going back and forth. So when he's back here to the left, it's negative distance, and then right here would be the center, probably the midline in our case, and then forward would be the maximum. So when time is 0, so let's go ahead and put our x and y axis. So this is our first point. It's just what we've been doing before. They're giving us two different points, just now we're doing it with words. So our first point when time is 0, so when time is 0, we have that he's 1 meter behind the center. So that first point is 0, negative 1. So 0, negative 1. Here's our first point. So that would be our minimum point. And we know that's the minimum because that is as far back as he goes. Then the swing reaches the center. You can guess that's the midline. So the center, pi over 6 later. So the times pi over 6, and the center would be 0 in this case. How do we know that? Once again, from the center, if you're behind the center, it's negative. If you're in front of the center, it's positive. So right between positive and negative would be 0. So let me just call this pi over 6, 0. Here's our other point. And since it's starting at the minimum and then going to the midline, this would be a cosine curve. So there's our cosine, and if you were to continue it, we'll go like that. So we got to go ahead and create our function a cosine of bt plus d. And be careful to put t. I put x the first time and got it wrong. So our amplitude, well, let's start with our midline first. Our midline is right on the x-axis, so our midline is 0. The amplitude, we're going up from the midline by 1. But in this case, it's a flipped cosine, so we'll put a negative. And then last, to figure out b, we need to know what the period is. Well, this is a quarter of our cosine curve, so a quarter of our way, a quarter of our period, a quarter of p, we'll say p is our period, is pi over 6. So I'll times that by 4 to get 4 pi over 6, or 2 pi over 3. So that's what our period is. So we know that that's not b, that's the period. So I'm going to take 2 pi over b, the formula for the period, set that equal to 2 pi over 3. You can cross multiply and solve, but you'll see that b has to be 3. Both numerators are 2 pi. So in order to make this equation the same, you would need b to be 3. Go ahead and substitute that in. Negative 1 cosine of 3t plus 0. And there is your answer there.